Nature is an inspiration for people. For example, airplanes were inspired by birds. In the same way, artificial neural networks were developed, inspired by neurons in the brain. Artificial neural networks are the core of deep learning. Complex problems such as image classification, recommendation systems, and language-to-language translation have been solved with this technique. In this video, we will cover artificial neural networks. Let's take a look at what we will learn in this tutorial. First of all, we will take a look at what artificial neural networks are. Next, we will explore what a perceptron is. Lastly, we will discuss how multilayer perceptron works, step by step. Let's go ahead and start with what an artificial neural network is. The first artificial neural network was proposed in 1944, but it has become very popular in recent years. Let's discuss why this approach has become popular in recent years. As you know, with the development of the internet and social media, the amount of data produced has increased and the concept of big data has emerged. This big data enabled the training of artificial neural networks. While classical machine learning algorithms fell short of analyzing big data, artificial neural networks performed well on big data. Another reason why this algorithm is popular is that the computing power of machines has increased. With the development of the gaming industry, GPUs have been developed. Neural networks were trained faster with GPUs. One of the reasons why this approach has exploded in recent years is the development of awesome architectures such as CNN, RNN, and transformers. In addition, these architectures can be trained more easily with libraries such as TensorFlow and PyTorch, which have been developed recently. Let's take a look at a biological neural network to better understand artificial neural networks. Here is a biological neural network. I'm not a biologist, but let's go over this neuron. This neural network consists of the cell body containing the nucleus, many branched dendrites, and a long axon. Notice that the length of the axon is much longer than the cell body. The axons are divided into many branches that combine with the dendrites or cell bodies of other neurons. Biological neurons generate electrical signals that travel along axons. If a neuron gets enough stimulation, it fires. In general, biological neurons work this way. This work may seem simple, but billions of neural networks can be managed by connecting neurons. Okay, we've looked at how biological neural networks work in general. Artificial neural networks were developed by imitating neural networks consisting of these biological neurons. Let's now look at the most basic unit of artificial neural networks, the perceptron. To understand the neural network architecture, we first need to understand the simplest neural network architecture, the perceptron. This architecture was developed by Frank Rosenblatt in 1957. As you can see, in this architecture, the inputs and output are numbers, and each input has a weight. For example, x1's weight is W1, x2's weight is W2, and x3's weight is W3. These weighted inputs are summed first, and then a bias is added. This sum is passed through a step function. This function can be, for example, a sine function. As you know, the sine function maps less than 0 values to -1, 0 values to 0, and values greater than 0 to 1. You can use a simple perceptron for linear binary classification. For example, a linear function of the inputs is calculated first, and then the result is positive if the result exceeds a threshold value. If it does not exceed a certain threshold, the result will be negative. It's very simple, right? But with this simple approach, AI tools like ChatGPT have been developed. A single linear function is called a threshold logic unit. A perceptron may consist of multiple linear functions interconnected in one layer. Look, there are 2 inputs and 3 outputs in this image. The layer with the inputs is called the input layer, and the layer with the TLUs that produce the outputs is called the output layer. Notice that all of the inputs are connected to all neurons. A layer like this is called a dense layer. Look, this perceptron has 3 different outputs. Note that the number of labels is 2 in binary classification. Since there are 3 outputs here, this task is multi-label classification. Of course, you can also use this architecture for multi-class classification. At this point, you can ask a question, such as how to train the perceptron. Let's briefly discuss the answer to this question. If you understand how a perceptron is trained, you will also better understand how neural networks work. First, assign a random weight to each input. The sum of the inputs is found, and then a bias is added to this sum. Remember, when one neuron triggers another neuron frequently, the connection between them becomes stronger. Inputs passing through neurons produce an output. This output is a prediction. The actual value is compared with the prediction, and the error is calculated. Weights are updated to make predictions, with fewer errors. Cool, we have learned what a perceptron is. Perceptron was a different approach, but failed to solve some simple problems like XOR. To overcome the limitations of the perceptrons, the multilayer perceptron was developed. Let's dive into multilayer perceptrons. Multilayer perceptrons consist of an input layer, a hidden layer, and an output layer. This is a simple multilayer perceptron. In this architecture, there is a hidden layer. If there is more than one hidden layer, it is called a deep neural network. This is where deep learning comes into play. Deep learning became popular with the development of modern AI architectures. In short, the inputs go through neural networks, and a prediction is made. But, how to improve the prediction of a neural network? This is where the backpropagation technique emerged. This algorithm takes a neural network's output error, and propagates that error backward through the network. So, the weights are updated. And this cycle continues, until the best prediction is obtained. Cool, let's discuss how neural networks work with backpropagation. First, a batch of data is taken. This batch number can be 32. This data passes through the whole neural network many times during training. The passing of all data through the neural network is called an epoch. Nice, we learned what epoch and batch are, which we will use very often in deep learning tutorials. A batch enters the neural network from the input layer. As the data passing through the input layer passes through the hidden layer, the output is calculated. These outputs are forwarded to the next layer. In this way, the inputs pass through all the layers, and an output is obtained. This is called a forward pass. The output of the neural network is a prediction. Note that the weights in each layer are stored. This is because the weights are updated, while the prediction error is propagated backward. You may ask, how is the error measured? For this, the loss function is used. The loss function compares the actual value with the predicted value, and calculates an error. Each batch passes through the neural network, and a prediction is calculated. And the error of this prediction is measured. This error is propagated backward, and the weights are updated. The other batch is estimated according to the updated weights, and the prediction error is calculated again. According to this error, the weights are updated again. In this way, all data passes through the neural network. Note that the initial weights are given randomly. Otherwise, the training will fail. Okay, we've seen how neural networks work. So far, I have explained the theory of artificial neural networks. If you understand the structure of this architecture, you can create better architecture. Deep learning is more like art than science. The better the model architecture you build, the better your prediction will be. Now let's take a look at the activation function in this architecture. Remember, the activation used in perceptrons was the step function. The activation function used in multilayer perceptrons can be a sigmoid, hyperbolic tangent, or ReLU. The most used function is ReLU. You may ask, why we use the activation function? We use the activation function because we want to add nonlinearity to our architecture. This makes our architecture more flexible. We cannot solve complex problems if we do not use activation functions. So far, we have learned the structure of neural networks and how they work. We also looked at the backpropagation algorithm. In the next video, we will handle how to implement neural networks with scikit-learn. That's it. Thanks for watching. Don't forget to subscribe to our channel and hit the bell icon so you don't miss the latest content about AI and data science. You can also follow us on other social media accounts. You can find the links in the comments. See you in the next video.